Hello, and welcome back to the MCAT grind. We have our last physics chapter, chapter 12, about statistical reasoning. And statistics, at its base, is just dealing with numbers and looking at populations and getting them into numbers. So, by dealing with numbers, we can look for trends and patterns. Starting with mean, median, mode. Mean is basically the average. They're all determinants of averages, but mean is the numerical average at which all the sum and are weighted based on how much they mean. So if you have a mean of between 1, 2, 3, 4, 5, mean you add them all together, which is 15, and divide by 5, which is 3. That's the mean. Where you add them all up, sum, and then you divide by the number. Median, basically you just circle the middle one and call it a day. The middle one of the set, and 1, 2, 3, 4, 5 is 3. And make sure you have to go from the lowest to the highest. If they're in random order, you have to sort them from lowest to highest first before you pick up the middle one. If there's 2, you find the average between the two middle ones. The mode is whichever one you see the most. Since every single one of them we only see one time, then the mode is just every single one of them. Right? So if there's 2 3s, for example, then that will be the mode. If there's 2 4s, then 4 will be the mode. Normal versus standard distribution basically shows that in the middle is where most people are concentrated, and to the side there are in the front and the head and the tail are pretty much equal in distribution. Equal amount of people being higher, equal amount of people being lower. Skewed basically shows that it's only concentrated on one side or the other. It can be left skewed or right skewed. Left skewed means that the mean is lower than the median and the mode. Right skewed means that the mean is higher than the median and the mode. Bimodal distribution means there's 2 peaks. For instance, some population patterns in genetics. Range shows between the minimum value versus the highest value. Interquartile range basically says that divides everything into quartiles. So first quartile, second quartile, third quartile, and so forth. So the first quartile is basically 1/4 of the entire number of how many ever positions there are, and that's a position of the number. So if I have 1, 2, 3, 4, the first quartile, there's 4 of these, right? So 4 times 1/4 of 1, and then that's position of the first quartile. And the third one is 3 or 4 times 1, 2, 3, 4. That would be the third one. So that's the third position. So 3 minus 1 is 2. So basically the interquartile range is 2. So anything that's 1.5 less 2 times 1.5, that is 3. So anything less than -1 or anything bigger than 3, 1.5 times bigger than 2, what is it? 2 times 1.5, 3. Anything bigger than that, that will be considered outlier. So 4 in this case becomes an outlier. We'll cross that out. Standard deviation basically says that we have a certain value that is deviating from the middle point. So if we have a standard distribution in every set, that if it's evenly distributed, 68% will fall within the first standard deviation range. So between here and here, that's the first standard deviation. If you go here and here, that's the second standard deviation. Here and here, that's the third standard deviation away. And that includes this whole entire chart. So this area is like 34%. This area is a further 13%-ish. And this area is like 2%. That's a rough estimate. Okay. We have probability now, which means probabilities, if it's independent, they just multiply by each other to find where they co-occur. So for instance, if there's only 1 in 5 people that hates ice cream and 1 in 2 people that hate chocolate, to find the number of people that hate both chocolate and ice cream, I'll just multiply the two probability. So half times 1/5, that's 1 in 10 people hates both chocolate and ice cream. If I want to find a number of people that hates either or, as long as they hate at least one of them, I just need to add the probability together and then subtract the probability where they coexist together, because it's like a Venn diagram thing. So them adding together is half times 1/5, that's 5 plus 2, that's 7/10, and then subtract 1/10, so that's 6/10. So 3/5 of the people hate at least one of them. Okay. Then we have type 1 error and type 2 error. Type 1 error basically says that we reject the null hypothesis when it's true. When we're doing research, null hypothesis is basically we're going in assuming that there's no difference between two measurements. And when there's no effect between two measurements, we say, okay, the measurement we fail to reject the null hypothesis. But if there actually is a difference, and we usually call that confidence between a alpha set to 0.05, that's basically a p-value, we can reject null hypothesis when the probability is less than that using a t-test. And a type 1 error is when we reject it when there's actually no difference between the two measurements. A type 2 error is when we don't reject it when there's actually a difference. So let's, for instance, I want to see whether trees or a plant that I watered with vitamin B or just normal water, if vitamin B adding the water helps the plant grow better. And in my measurement, my null hypothesis is saying that it doesn't. It has no effect. If I reject my null hypothesis, that means that there actually is a difference, and vitamin B actually helps it grow more, or the other way around. Now, if I reject it when it's actually null hypothesis is correct, such as if I say, oh, there actually is a difference, but in reality there's no difference between the two values based on statistics, then that's my type 1 error. And I want to make my type 1 error as small as possible, but that's usually set to 0.05. And by my type 2 error is when, they appear to be the same. However, the vitamin B actually does increase it significantly, and that's a type 2 error. Power is basically the ability to correctly reject the null hypothesis, and that's constituted by 1 minus the type 2 error. Confidence interval is 1 minus alpha. So basically, if you're 95% confident, that usually constitutes that you're within the 3 quartile range. And Z versus T-score will be provided on the MCAT table, which shows you what value you'll need to multiply by the standard deviation. If you're looking within a 2 standard deviation away, that's usually 1.96 for 95%. You do 1.96 multiplied by the mean, and then you should get your values, and you just subtract that mean by above or below, and you should get your range. And we also have type of graphs: the pie graph, bar graph, the whisker-ish graph, the box plots, as well as generic graphs for you to recognize. These are just the types of graphs you'll need to see. That's pretty much it.